Today, this video is the second of two videos on signed numbers. The first thing we'll go into is multiplying and dividing signed numbers. So when you're multiplying or dividing signed numbers, you would follow the exact same steps as if you were just multiplying whole numbers, fractions, or decimals. But the one thing you need to consider is that when you're multiplying numbers, their sign is going to be affected by the signs of the factors. When you're multiplying two things, if they have the same sign, meaning that they're both positive or they're both negative, the product is going to be positive. On the other hand, if you have two factors that you're multiplying and they are different signs, say you have a positive and a negative, or a negative and a positive, it's going to be a negative product. And this is when you're multiplying two. If you were to multiply 3 or more, what you do is just count the number of negatives. If there are an even number of negatives, then it would be positive. If there's an odd number of negatives, it will be negative. But if you want to do it one by one, you can just multiply from left to right. So we'll just do a few examples. If I was to have -4 times -7, since both numbers are negative, I know it's going to be a positive number, which is 28. If I had -4 times -3 times -1 times -2, what I would do is, for me, I would say either I count all the negatives, or you can say, okay, a negative times a negative is positive, times another negative will make it negative, times another negative will make it positive again. So this is going to be a positive number. And I'm just going to multiply all of the absolute values. 4 times 3 is 12, times 1 is 12, times 2 is 24. Positive 24. But again, the product of an even amount of negative numbers is positive. If I had instead -10 times -3 times -2, 10 times 3 times 2 is going to be 30, times 2 is 60, and then negative times negative times negative, since I only have 3, it's going to be -60. And again, if you are multiplying fractions, then the same rules apply, but you're just going to use the number of negative terms to determine the sign. Now we're going to go into dividing signed numbers. When dividing signed numbers, again, same rules apply, but if they have the same sign, it'll be positive. Different opposite signs, it'll be negative. So positive divided by a positive is positive. Negative divided by a negative is positive. Same sign, positive. Different signs, positive divided by a negative will be negative. Negative divided by positive will also be negative. The sign is determined the same way as it is in multiplication. So a few more examples. We have -60 divided by 10, which is positive. We have a negative divided by positive. Of course, that's going to give us a negative number. 60 divided by 10 is 6. So -6 is our answer. If I have -45 divided by -9, I have a negative divided by negative, so it will give me a positive quotient. So 45 divided by 9 is 5. Negative divided by negative is positive. Positive 5. And again, if you were to do any fractions, same rules would apply. You flip the divisor and then use the rules for multiplying fractions. I also wanted to talk a little about operations involving 0. So whenever you're adding something to 0, it's going to be the same number. So a plus 0 is the same as 0 plus a, which is just a. If I have negative 5 plus 0, that would just be 0. And if you're subtracting 0 from anything, it would just be the same number. A minus 0 is equal to a. If I had 13 minus 0, it would be 13. If I'm subtracting something from 0, 0 minus a, this is different on the other hand. So we have 0 minus a is the same as negative a, or 0 plus negative a. So 0 minus negative 5 is going to be positive 5. And then multiplying anything to 0, if we have 0 times a, it would be just 0. Of course, 0 times negative 7 is just going to be 0. When using 0 with division, there are two different options, and I want to just specify first. If a is not equal to 0, then 0 over a, 0 divided by any non-zero or any number that's not 0, is going to be 0. However, if you put 0 in the denominator, a over 0, you can never divide by 0. So this would be undefined, as would 0 over 0, undefined. That's like the biggest no-no in math, right? We can never ever divide by 0. Now we'll go into powers of signed numbers. So this is when we're applying exponents. So powers again are when we apply exponents. If I had 5 squared, just means 5 would be multiplied to itself, where it is a factor 2 times, so 5 times 5, which is 25. And since it's both positive, that's fine. 2 raised to 4 is just 2 times 2 times 2 times 2, which is 2, 4, 8, 16. However, if you have a negative number inside parentheses, this would be negative 3 times negative 3. It's important to note that the exponent is only applied to what's directly in front of it. Directly before it. Unless there are parentheses. Meaning that this negative 3 squared, I multiplied negative 3 by negative 3. I included that negative sign because it was inside the parentheses. However, if I had negative 3 squared, that would be different. It would be the negative, and that's 2. That exponent of 2 is only touching the 3. So it would be 3 times 3. And negative 3 times positive 3 is negative 9. This negative 3 squared within parentheses is positive 9. It's important to know that difference. Another popular one is when you have a negative 1 raised to an exponent. So if you have negative 1, it's just going to be 1 times 1 times 1 times 1, right? Or negative 1 times negative 1 times negative 1 times negative 1. So the absolute value is always going to be 1. You just need to determine the sign. And it's going to follow the same format as we do with multiplication. If you have a negative number raised to an even number, it will be positive. So this is going to be positive 1. But if you have a negative number raised to an odd number, make it 15, that'll be negative 1. It'll be a negative number. You write this. negative raised to odd is negative. Negative raised to even will be positive. And sometimes we'll even see a negative outside of the parentheses. And if it's something like that, then you'll actually apply it last. For example, negative 2 squared. I know negative 2 squared is going to be positive 4. So this will be negative times positive 4, which is just negative 4. If you have a negative 2 cubed, negative 2 cubed is going to be negative 8. So it'll be negative 8, which gives us, of course, negative is positive. This is definitely something that a lot of people could use some practice with. I suggest you look up some worksheets with answers online, and then just practice it on your own and then check your answers. Now when we talk about an exponent of 0 as an exponent, anything raised to 0 is 1. 2 raised to 0 is 1. So when exponent applies to whatever's inside the parentheses, if I had a fraction in here, negative 1/2 raised to 0, it doesn't matter what the number inside is, whether it's positive or negative, or if it's big or small, it's going to be equal to 1. If I had negative 4 raised to 0, it would be 1. And lastly, we're going to be covering square roots of signed numbers. So we know that a square root is the number that which squared equates the original number within the radical. So if I was tasked to find the square root of 36, this is just 6. Note that we're only taking the positive square roots when we have that radical, unless there's a negative sign in front, but it's only going to be positive otherwise. Square root of 0 is 0. Fractions still work, so 25 over 49. This is just the square root of 25 over the square root of 49, which is 5 over 7. If you have a negative on the outside, that's fine. Negative square root of 16 is actually going to be, square root of 16 is 4, so I'm going to apply that negative after. And if you have negative square root of 4 over 9, I'll take the square root of each of them. So we'll have negative 2 over 3. It's important to note that at this point, we're only dealing with real numbers, so we are not taking any square roots of negative numbers. Taking the square root of a negative number would give us an imaginary number, which is not what we're covering in this video. Anyways, that is it for this video. I hope you all learned something and that you're having a great week. Thanks again.